I'm just going to do a quick bit of more drawing on this power switch, just because I realised some things that I could add to it to make it better. So I'm just going to do a quick bit of modelling on it. Okay, there we go. I just basically cut the sides out to try to reduce the amount of plastic in it, make it a bit cheaper to make. Added a bit of support in there, just a bit more strength, and I chamfered the bottom of the hole so we can put some countersunk screws in there. Probably still quite a bit of plastic in there, but it's a bit smaller. We'll just save that. Go back to the assembly. Yeah, there's the updated. Just looks a little better. Still does exactly the same thing. You can almost bring those screws in a bit tighter, but probably a bit easier just to leave it square the way it is. So yeah, there's a bit of an update on the power switch. I'm also going to do a little bit of, I'm thinking of putting some wire and extra plugs out the end, just to finish it off a little bit more for my own personal reasons, because I want to put plugs on the switch so we can unplug it in case it breaks and bolt in a new one. So I'm just going to put some plugs on. I've just put in a, this is a female gold connector, 4mm gold connector, and this is a pre-assembled gold connector. So I'm just going to draw a bit of wire out each end and then stick the gold connectors on each end. I like using gold connectors recently. So just, when I do my wire, what I'm actually going to do is draw it in my layout that I drew in the actual model. So I'm going to draw some wire in here, which is basically just going to be a rectangle, like that. That's all the wire is. So I'll just make it so it sits inside the ring connector. And we'll make it come out about 20mm just for the look of it on each end. I believe the it's around about 4.5 and 4.5 divided by 2. Make those equal. I'll have to double check that. It's not a big deal though. Y is just a cosmetic thing. But anyway, that's those two bits of wire now saved in that sketch. But I'm not actually going to draw it in this model, because if I draw it in this model when I get it 3D printed, I'll be 3D printing random cylinders. So I'm going to create a new part. I'm then going to use derive component, which is next door to the parameters component. So if we derive a component, we then go back to common parts, down to power switch body, which is in here somewhere. Where are you? Power switch body. Open that up. We're not going to derive a solid body, so we can turn all the solid bodies off. We're going to derive a sketch. So we're going to derive the switch layout vertical. And that's the sketch I just drew with the wire. So it's actually, that's the same sketch as the layout of all the ring connectors, so I know the wire is going to be on the center line of the ring connectors. And I think that I'm going to draw the wire just as a single part, even though there's two different bits of wire. But I'll just draw them in the one part because it's not necessary for them to be on different parts. And if they are, we can do that later. So I'll just do a revolve for that cylinder. That's that bit of wire. Turn the sketch visibility back on. We'll do a revolve on that one there as well, on the center line. And that's that bit of wire. Turn the sketch back off. So that's the 2 bits of wire, and they're exactly the right dimensions and positions to fit in the switch perfectly. And I've got to change the color of those. I'll make it black. I'll put my switch on the -1. And we'll save that back in common parts. Where are you? Power switch, wire. Save. Done. Okay. Copy the part into the assembly. Paste. Now when you do what I just did with the deriving a sketch into another part, what you can do is, instead of constraining this into the assembly, you can simply change its position to 0, 0, 0 and then ground it. Because the first part you put in there, well, this body is already constrained to 0, 0, 0. If I constrain these to 0, 0, 0, they will be sticking out in the right position. And that means that if I ever update it in the future, I don't have to worry about constraints getting broken because parts have moved. It does technically mean that they're not constrained to each other, but because it's grounded, I can't actually move it. So it doesn't really matter too much. And I'll just insert my gold connectors onto each end. And that would be an updated switch model. With the wire attached. It looks a little long. And in real life the wire is not going to be straight. But we'll model it straight, just for the fun of it. So that's an updated model of the switch. I'm just going to copy that and put it in here. Yeah, it does look a little long, but we can always make these shorter. So I guess next time I make a video, I've got to actually put the mounting holes into here. I wonder if I can do that right now. It shouldn't take too long. So if we put it in just the top sketch here. Yeah, there's the top panel. And there's the skeleton. If we find, where did I put the sketch for the top panel? Top cover, there it is, the bottom one. Edit sketch. So we just need 5 holes here. So if I go to parameters, if we hit link at the bottom, this link button, it's looking for an Excel spreadsheet. I don't like Excel spreadsheets, so if we change the file type to an Inventor file type, then we scroll down to, where's power switch? I keep losing the bloody thing. Power switch body, there we are. It brings up a list of all the parameters I made in the power switch model. And the ones that I want to use are this reference one. Remember we created a reference one? That's a switch brass screw protector OD. We want that. We want the size of the mounting screws. And we want the mounting screw space lengthwise and widthwise. So if we take those 4 dimensions from the model of the switch and link them into the parameters list for the robot skeleton, it'll be one of these grey ones here. There we go, there's this power switch body. And it's got those 4 dimensions. Okay, done. So now, if I draw just a circle. We dimension it. We list the parameters. Nice big list of parameters. We've got the switch brass screw protector ID. Done. Finish. Update. Save. Go back. Here's the model of the top cover. We update that first because there was a little, I was too quick. There was a little symbol in there telling me to update. So it tells me that the sketches in the derived parts have been updated. And on reflexes I hit the update button before I told you what I was doing. Anyway, we modify this feature. There we go, there's our 5 holes. Turn that sketch back off. So there we go, we've just drilled 5 holes into our top cover, which will mount the screws, the switch. If we save that, close it, go back to the assembly, there's our 5 holes. Now I'll constrain the switch against those holes. Right, so that's that switch in there. It actually looks like it fits pretty well. I can move it closer to the front, but it does look like that it fits on top of the battery, which I didn't check. If I can measure this, select the top of the battery, and then we'll select the underside of the switch as soon as that face. There's still 7mm clearance between the switch and the top of the battery, so that fits nicely. Even though from the looks of it, it is a pretty big switch. And that looks like a nice spot on the robot that has very little chance of being hit. But I still might shift it further to the front. And I should also show you that deriving the dimensions is handy, because if I go back here, if I go back here, if I change the parameter, like if I decide my switch is too wide, and I change the width between the mounting holes to 20, done, update, still makes it, and actually still looks like a good switch to make. We might actually leave that at 20. Save. Yeah, beautiful. We then update this model. Computer thinks, and there we go. The mounting holes on my top plate have also moved to match the switch. So that means that no matter what happens to that switch, I know that because I use the same dimensions in both models, that my model is 100% correct, and no matter what I do to that switch, my model for Avenger will remain 100% correct. And that's why I love top-down. You only change one thing and it updates everything else. I'll just quickly move that forward. Top cover, make it 180. Beautiful. Update, update, update. Oh yeah, that'll work. The wire can still swing around. We've got the battery leads out the back, come in, plug into there. Or might loop them around the side and plug them into there. Yeah. And then that goes out and plugs into each speed controller. Lovely. Yeah. I might actually save that little plastic model and upload it onto Shapeways and find out how much it costs to make. And if anybody wants a model of that switch, I can send them a model and they can print one themselves, I guess. Yeah. That was a pretty easy video.